Chain rule. You have to use the chain rule whenever you're dealing with a composite function. What do I mean by a composite function?
One more
A function within a function is what we're talking about with composite functions. So when I have a function inside of another function, that's when I have to use the chain rule. So I'm going to go ahead and give you the general form of the chain rule, and then we'll come back and apply it to some problems. Alright, so I'm dealing with h of x, which is a composite function, because you can see that g of x is inside of f. So that's what makes it a composite function. So I'm going to go ahead and give you the derivative of it, and then we will talk. That's how you take the derivative of a composite function, and that is called the chain rule. Here's how you remember it. Or if I ask you, what is the chain rule, this is how you spit it out at me. You take the derivative of the outside, the inside stays the same, times the derivative of the outside. Times the derivative of the inside, thank you. So, derivative of the outside, the inside stays the same, and then times the derivative of the inside. That's how you remember the chain rule. One more time, derivative of the outside, the inside stays the same, and then times the derivative of the inside. That's the chain rule. Let's look and see how we can apply it to some problems. Alright, let's look at example 3 up here on the left. It says f of x is equal to 2x plus 5 to the 10th. So let's first make sure that we can see that it is a composite function, and let's talk about what is the inside and the outside function. Can you guys see that it's a composite function?
Yeah.
Okay, what is my outside function?
X to the 10th.
X to the 10th, and what's my inside function? 2x plus 5. Everybody okay with that? I got the exponent of the 10 on the outside, and I got 2x plus 5 on the inside. So when I'm talking about outside function, I want you to think of that 10th power. When I'm talking about inside function, I want you to think 2x plus 5. Okay? Now, if I don't have the chain rule, what do I have to do to be able to find the derivative of 2x plus 5 to the 10th?
Use the product rule.
I can't use the product rule because I don't have things being multiplied. I have to write out 2x plus 5 10 times and then multiply all of that out.
Oh.
That's what I have to do without the chain rule. So that's why the chain rule is handy. So, again, my outside function is the power of 10, and my inside function is 2x plus 5. All right, who can give me the chain rule back at me again? What's the chain rule? Very good. Derivative of the outside, the inside stays the same, and then the derivative of the inside. So, again, my outside function is that 10th power. So how do I take the derivative of a 10th power? What do? I move the 10 to the front. I have the 2x plus 5, and now my exponent is 9. So as you notice, we did the first part of the chain rule. We took the derivative of the outside, and what happened to the inside? It stays the same. That is key in using the chain rule. You must keep that inside part the same. Because what will happen is, somebody's going to take the derivative of the outside, but at the same time, they're going to take the derivative of the inside and just put them together. But that's not how it works. Take the derivative of the outside, the inside must stay the same. Now we take the derivative of the inside, which would just be 2. So my final answer would be 20, 2x plus 5 to the 9th. All right, let's move on to example 4. F of x equals 2x plus 5, or the square root of 2x plus 5. So what's my outside function? Radical x. What's my inside function? 2x plus 5. So what do you want to do to the radical? Turn it to the 1/2. So we want to think about this as 2x plus 5 to the 1/2 power. So we have to take the derivative of the outside first. So what do I do to take the derivative of the outside? Power rule. So I bring the 1/2. Inside stays the same, and now it is negative 1/2. Bring the power down, subtract the power by 1. Now I need to take the derivative of the inside, which is 2. Alright, let's clean it up a little bit. What happens to the 1/2 and the 2? These two cancel out. So now I'm dealing with 2x plus 5 to the 1/2. So what do I do to that? I put 1 over 2x plus 5 to the 1/2, or I could do 1 over the square root of 2x plus 5. Either way. We have y equals 1 over 4x minus 3. And when you first look at that, you might think that it is not a chain rule problem. What type of problem do you think that is?
Quotient.
Quotient rule. Okay, you might think that's a quotient rule.
1 over.
But I want you to change it to a chain rule. And here's what it looks like if you change it to a chain rule. I make it 4x minus 3 to the negative 1. You only want to do that if there is just a number in the numerator. If you have a variable in the numerator, you will not rewrite it like I've rewritten it. If there's a variable in the numerator, how are we going to take the derivative? We're going to use the quotient rule. But if there is a number in the numerator, then we can rewrite it and take the derivative using the chain rule. Okay? So, now I'm ready to take the derivative. So I have to take care of the power first using the power rule. So I bring the negative 1 down. 4x minus 3 stays the same, and now I'm dealing with negative 2. So that's the derivative of the power. Now I have to take the derivative of the inside, which would be 4. So what does this look like when I clean it up?
Negative 4.
Negative 4 over 4x minus 3 squared. But again, we only rewrite a fraction when I have what in the numerator? Just a number. If there's a variable in the numerator, do not rewrite the fraction. Use the quotient rule. Okay, we only want to rewrite it if there's a number up there. All right, number 6. I have y equals 3x squared minus 2x plus 1, and then we're cubed. So my outside function is the power, and my inside function is the polynomial. So I need to take the derivative of the power. If I take the derivative of the power, what does that look like? Bring the 3 down. Inside stays the same. I'm dealing with a square. So that's the derivative of the outside, which is the power. Now I need the derivative of the inside, which would be what? 6x minus 2. And I'm happy with that. Let's look at 10. What do you notice about 10? I have x squared times 2x minus 3 to the 4th.
We have 2 sets of exponents.
Alright, I've got 2 different exponents. Well, what do you see? What rules do I need to use?
The power rule, your product rule, and your chain.
Alright. First thing I need to notice is that I have x squared times 2x minus 3 to the 4th. So the first thing I need to notice is I've got 2 things multiplied, which requires me to use what? The product rule. So the first thing I have to do is start by using the product rule. Okay, Amelia, what's the product rule again?
First times the derivative of the second minus second times the derivative of the first.
Plus. First times the derivative of the second plus the second times the derivative of the first. So I've got the first, which is x squared, and then I need the derivative of the second. What do I have to do to take the derivative of the second? I have to use the chain rule. Okay, so what is my outside function? The power is my outside function, so that means I need the power rule. So that would be 4. The inside stays the same and cubed. And the last thing I have to do, derivative of the inside. What do you think is pretty common for you guys to leave out or forget to do?
The derivative of the inside.
Derivative of the inside. Okay, most of you guys will handle the derivative of the outside, but you will forget to do the derivative of the inside. So that's first times the derivative of the second. Now I need the second, 2x minus 3, times the derivative of the first, which would be 2x. So this one I can clean up just a little bit to make it look a little prettier. It would be 8x squared, 2x minus 3 to the third, plus 2x minus 3 to the fourth. 13, I have y equals x divided by the square root of x squared minus 1. What do I have there?
And variable in the numerator.
A variable in the numerator, which means I can't do what?
The chain.
I can't rewrite it, is what I want to hear you guys say. I can't rewrite it. I can't move the denominator to the top like I did earlier. So, since I can't move it, that means I have to use what? The quotient rule. Jasmine, what's the quotient rule?
G times derivative of F over
Whoa.
minus.
That's not how I asked you, remember?
That's how I had to remember
Oh,
it.
it's G's the bottom.
So bottom times derivative of top minus bottom, top times derivative of the bottom over derivative of the bottom square.
No,
I mean,
just the
the
bottom square. Okay, so bottom, which would be x squared minus 1, times the derivative of the top, which would be 1, minus the top, times the derivative of the bottom. Now, what do I need to think of this as? I need to think of it as x squared minus 1 to the 1/2. So, what's my outside function? The power is my outside function, so I want 1/2. Inside stays the same. My new exponent is negative 1/2. And what can I not forget to do? I need the derivative of the inside. Don't forget that. And then I want the bottom squared. What do I get when I square the bottom?
X squared.
I get x squared minus 1. Okay, we need to clean this up a little bit. So this gives me the square root of x squared minus 1. What happens over here?
2 and 1/2 cancel.
The 2 and the 1/2 cancel. X and x leaves me with x squared on the top, and this has to move back to the bottom. And this is all over x squared minus 1, which has a fraction and a fraction in it, which I don't like, so I've got to do something real easy to get rid of it. What is that? Multiply by that radical. So in the numerator, when I do that, that gives me x squared minus 1 minus x squared over x squared minus 1 times the square root of x squared minus 1. What happens in the numerator?
X squared's cancel.
So I'm left with negative 1 over x squared minus 1 square root of x squared minus 1.